Hello there, what's up? So today's video is going to be about Chat GPT and is it good for engineers or bad for engineers. So before we go, and you might have been seeing Chat GPT trending up on the internet and a lot of people using it so far, but I've tried to research a little bit on it and try to see if it's good for us or it's bad for us. So let's begin by seeing how engineering usually works. So usually engineers work with codes and then with software and then engineering judgment. So how this goes is, when you're an engineer, you usually design not by your own self or your own formulas, but formulas based upon a certain code. For example, for design of concrete structure, we usually use this code, the American Concrete Institute, in much of the world, but depends upon your locality and stuff. The reason we do this is because we want the risk majorly to transfer over to these code writers. So we say that we use this code, and so if there's a problem tomorrow, we can rely on the code, the people who wrote this code, and shift the blame over to them. It's not just the blame, but since research and actual time goes into these codes and stuff, so these are basically accurate. We use the formulas and everything and depend upon these codes for the most of the matter. For example, if you're doing structural analysis, the modeling assumption come from this part of the code, etc., etc. So once this is an integral part of engineering, obviously, and then there comes the software. So in software, usually what we do is we make a model, put the loads and everything on it. This is basically to make the life of an engineer easier. It's not actually important. You can skip this part, but the result, like making a structure like this and running an analysis on it, might take you weeks. But for softwares, it's easy because they have finite element analysis and everything going on in the background, so they do it way faster than we do. But what happens after this is that once we have the answers to all the analysis and stuff, we don't usually design these softwares themselves. Even if we do, we basically recheck them in with our own hands or with tools like this one, like I showed you last time. So engineers have certain checks in place so that everything is okay, because at the end of the day, you're responsible for it. You're the one signing it, and you're the one responsible for it. So this is how engineering works. We have codes that we rely on for most of the part. Then we have softwares that make our life easier, but that at the end of the day, it depends upon you, your engineering judgment, and what you learn and what you can understand. And you're the person in charge of everything, so you're responsible. Now how exactly does ChatGPT get into all of this? It makes your life sort of easier by giving you, enhancing your capability to judge something, because not all of the time you have access to all of these codes, nor do you have the means to go through all of them to just find what you're looking for. So how ChatGPT works is it makes your life easier by interacting with you in a natural way. I'm going to show you how it does that in a moment, but just to give you a heads up, it uses an open access database to give you an information. So for example, it might not be able to, if it's able to access a database, it will give you information from that database. But if it isn't, like certain stuff aren't open source, or certain companies might break off the access to it at a certain point. Like for example, Elon Musk himself did that. He paused OpenAI's chatbox access to Twitter database on December 4th. He did that because he said that it was going away from the open stuff, OpenAI stuff, or it would be becoming monetized. So he wanted to get money for it. So AI uses interaction with people to get better at stuff. That's the main premise of the Chat GPT. It tries to interact with you and learn from you. So you tell it that this what you said to me is wrong and this what you said to me is right. So at the moment, it's not the best. It doesn't give you the best advice, but it will give you good advice. So to give you an example of what it does good and what it does wrong, here's an example of how exactly you could approach it. So for my example, I asked it to give me. So let me just give you a premise of what I want to do here. You see, what I wanted to do was paint. Let's say we have a bridge like this, and it had abutments on each end. And let's say this is just a simply supported bridge with bearings over here. Let's just see these are bearings. And what I want to do is I want to see how much shear we're having in this area, in this area of the bridge. I just want to see how much shear is allowed for the ultimate limit state, so that I can use it in the design as a reference. I'm doing this from my recent fragility curves. So I asked it that I give it a simple question: please tell me the allowable displacement in a single span bridge bearing paths for the ultimate limit state. What it told me was that you should refer. It is recommended that you should consult a professional to refer relevant codes. Since I am the engineer and I want to know which code it is, so I told it, please tell me a design code and standards in use for it. It gave me a bunch of codes. You get my point here? It's basically just trying to tell you that you can use this information that I got from the internet, the open access information. The closed access information isn't available to it. For example, if there is a code, for example, if it can't exactly give you the information or the codes used by the US Navy or the US Army, which isn't necessarily open to public access. It might be, it might not be, but at this point it isn't. So then I asked it to give me an RLRFD allowable displacement in it. So it told me that it specifies a compression distance of this much and a shear displacement of this much. Then I asked it which part of RLRFD gave you these things, and it told me part 5 in bearing. So then I asked it which part specifically gives you this for the elastomeric bearings, since those are the ones that are commonly used. It told me in section 5.10.2. So when you open up section 5.10.2, this is a 2012 edition. The Chat GPT version might be going for an older one, because in section 5.10.2 there are hooks and bends. So instead of that, I searched it up over there, and that specific section is present in 14.7.6. When you go to 14.7.6, it doesn't give you the specific values Chat GPT is talking about, which are 0.1 inches or 0.06 inches. Again, you have to find these values for yourself. These aren't exactly given here. They're given in formulas which you have to derive. So what I wanted to tell you is that engineers should not blindly trust the Chat GPT, because it's not exactly giving you the right answer. It's giving you references to go over there and learn and understand it. So the trend that I've seen in the past few days is that people usually try to just give it a question and take its answer for granted. Don't do that. Why don't do that? Because it says it's here itself that may occasionally generate incorrect information, may occasionally produce harmful instruction or biased content, and is limited knowledge of the world and events after 2021. So as an engineer, you should not rely more on ChatGPT, even if in 10 or 20 years it comes to a level where its information is better. But even still, the best thing about ChatGPT though is that if you give it a programming problem, like program a code for me that will analyze a simply supported beam for a uniformly distributed load. So you can see over here it's doing it rather in a fast way. The main idea is that it can help you with computer type of stuff really easily. Well, what's it doing here? It's giving you the maximum bending moment and maximum deflection. The problem is what it asked for me to analyze a simply supported beam. I didn't ask it for the maximum bending moment or the maximum deflection. It assumed that I was asking for it. Let's see, I didn't I did not ask for the maximum values. I need a general code. Let's see what it does now. Apologies for here for general uniformly distributed codes. As you can see, it's doing the same thing all over again. It's not giving me, a general Python code. It's just giving me a maximum code. So this is for short problems. For example, the problem over here is that let's see. What I wanted to ask her was something like this. Let's see. Not here. This is the sort of thing that I wanted. So let's see. What I thought she would give me was something like this: a simple UDL of, let's say, 10 kips from the 0 all the way to 20. If I add this, it'll give me the moment diagram or something like that, or analyze it for 180 kip here and 20 kips there. So I wanted a code like this, to be able to, give me general answers, but it didn't do that. So you get the point. What I'm trying to get to is that it can give you, it's not exactly accurate, but it'll give you, satisfying answer for certain problems and not for others. So I think that's about it. What you should do is that, even though it's not updated, it's not good, but it's a good reference. You should use it, but keep in mind that you're the engineer, you're the responsible for everything in the end. So try to keep that in mind. Well, thanks for that. Have fun.